of any town at a particular time t. Population increases at the rate of proportion to itself. So you can write dp by dt because the the observation is going on with respect to time t. So that's why it is proportional, he said, to p. So growth means dp by dt, okay, is proportion dp by p,
E by
dp by p. So for removing this proportionality constant, we will select some number dp by dt is equal to k into p, where k is some proportionality constant. Okay. And the next thing, we will solve this equation. Actually, it is a differential equation. So first of all, we will move this dt to right side like this. And variable separable, that means 1 by p dp is equal to k into dt. And next in this step, we will integrate to remove this differential part. So 1 by p dp will be log p is equal to k into t, some constant c. For identifying this constant c, what we are doing is at a time t, equal to 0, that means at starting, p value will be p naught. That is what initial conditions. These are called initial population. Initial population p naught. Okay. So let us substitute these values. So in the place of p, I am replacing p naught equal to k into t value is 0 because initial time is 0. So c value will be log of p naught. So after getting this constant value, we will substitute this value in the equation. So log p is equal to kt plus log p naught. Okay. Now we will move this log p naught to left side. Log p minus log p naught is equal to k into t. So log m minus log n is log of m by n. Log of p by p naught is equal to k into t. And then we will remove this logarithm. So it is a base e. So you can write p by p naught is equal to e power kt. Okay. This implies p is equal to p naught into e power kt, where k is any positive. So similarly, you can define the other things also. This is the formula we are going to use in population growth. So this is the best application of differential equations. If it is also like, if it was a bacteria in a certain culture, at any time, the bacteria growth n will be, or number of bacteria n will be n naught, where n naught is the initial bacteria, number of bacteria, into e power k. T will be at particular time, the number of bacteria. Okay. Similarly, you can also use radioactivity decay. Radioactivity decay, for this case, M is equal to, M means mass of the radioactivity substance. M naught into e power kt. We will use the same formula. Here k will be negative because why it is called decay. Growth means k value positive. Decay means k value negative. Okay. In general, you can say simply y is equal to y naught into e power kt. Okay. If K is positive, you can understand it is growth. If K is negative, you can understand it is decay. Okay? Understood this concept? The next most application, differential application is application number 2. So Newton's law of cooling, it states that rate of heat loss of a body is directly proportional to the difference of the temperature between the body and its surroundings. This is the statement. Okay. So again, the statement is the rate, the rate the rate of heat loss, the rate of heat loss of a body, a little bit it is looking like physics, but it is most interesting fact about differential equations. Body is directly proportional to directly proportion to difference difference in temperature, difference difference in temperature between the body, between the body and its surroundings, its surroundings. Okay. So according to that, we will take some indicators, like for example, the rate of change of temperature T of a body is directly proportional to the difference between T and the temperature T dash of the surrounding medium. So rate of change means dt by d small t. With respect to time, the rate of temperature is dashly proportional to body's temperature. Difference is proportional to difference of body temperature and surrounding temperature. Okay. Surrounding temperature is T dash. Body temperature is T. Okay. So you can write dt by d capital T by d small t is equal to minus k into t minus t dash. Why minus k? Because the temperature rate is always decreasing. Yes or no? Even though Earth's heat is always, according to time, it is cooling. So that's why minus k is used here. And remember, k should be positive. And where is a k is a constant. Okay. So we will solve this equation. Remember this equation. This equation is used for cooling whenever the question consists on temperatures. If T is greater than T dash, T is greater than T dash, then automatically dt by d small t will be negative. It means temperature of a body is decreasing. Decreasing. If t less than t dash, that means dt by dt will be positive. That means temperature is increasing. Body temperature is increasing. Okay. And one more interesting application of differential equation is third application, carbon dating. So this is also known as radiocarbon dating. Carbon dating, so C14, carbon dating, the operation will be conducted on C14. This is called C14 method also. Okay. So the amount of C14 in a sample from a dead plant or animal, or it will be somewhere else if you found that, compared with the amount of carbon 14 present in the living plant or animal, estimate when the plant of animal died. So let M be the mass of the carbon 14. M be the mass of C14, C14 at a time T, at a time T. Then dm by dt is equal to minus km. dm by dt is equal to minus km. Okay, we will solve this differential equation. dm by m is equal to minus k into dt, and we will integrate on both sides. So therefore, we know that log m is equal to minus kt plus c. So at initial conditions, we will apply. Initial conditions means, t is equal to 0 and m will be m naught. So we will substitute these values in the equation. Log m naught is equal to 0 plus c. Therefore, c is equal to log m naught. We will substitute this c value in the solution. So log m is equal to minus kt plus log m naught. Therefore, log m minus log m naught is equal to minus kt. This means log m by m naught you can write according to logarithmic properties. Therefore, m by m naught is equal to e power minus kt because logarithm has base e. So you can write from this m is equal to m naught into e power minus kt. So from this equation, we can find particular mass in the mass of the carbon 14. Next, the most important and last thing is drug assimilation in the blood, like dope testing also conducted by this method. Um, the fourth application, drug assimilation, assimilation into the blood, drug assimilation into the blood. So what we do, first we will give the intake, the drug will be intaken, and so we will format GI tract, and we will format digestion and into the blood, and will be formed as tissues. So this is the process. Okay. So what we do is in this process, so rate of change of drug in GI tract is equal to rate of change of drug intake minus rate of change of drug leaves in GI tract. Okay. So let us suppose define some mathematical relations. So x of t is called amount of drug in GI tract at a time t. Amount of drug in GI tract. Y of t is equal to amount of drug in blood. Amount of drug in blood. Okay. So what is GI tract means? So you can form a relation. The first question is in an exponential growth model, exercise 8.6, first question, in an exponential growth model, y is equal to y naught into e power kt. Satisfied the conditions, number one, y of 0 is equal to 5, and growth rate is r is equal to 2%. Second problem, in this same scenario, second question, y of 1 is equal to 1 and y of 10 is equal to 100. Actually, if you observe here, you can find differences in these two questions. In the same question, you can find one case one clues are given, initial conditions are mentioned, but the other thing is rate of growth is given. In the second problem, both are conditions were mentioned to create a equation. Okay. So let us see how we can solve this kind of problems. Write down solution. So first write down given y is equal to what is the condition? Mention it. Y naught into e power kt. Y naught into e power kt. So we will substitute the values. What are the values given? Y of 0 is equal to 5. What it means? It means t value 0, y value 5. Okay. So we will substitute here. Y value 5. Okay. And y naught value we don't know, which is initial value. And e power, oh, just wait. Here, y naught. Y naught is 5. What is y naught? Y naught is 5. Okay, you can write this one. Y naught is 5. So y is equal to 5 into, what is this value? Uh, k into t value 0. That means y value 5. Because e power 0 is 1. Okay. So therefore, you can write y is equal to 5 into e power kt. Also, growth rate was given to you as 2%. Okay. Growth rate means dy by dt, that is growth rate of y. How much? 2% of growth rate y. 2% means 2 by 100. So 1 by y into dy, just we have dy by dx value. Say this is equation 1. And we already having y value. Okay. This value. Take this and differentiate it. Look at this. 1 is dy by dt, and here also we got dy by dt. So that means we can equate both of these values. Okay. So 1 dy by dt means 5 into e power kt into k is equal to, here in this equation, 2 by 100 into y. Okay. So y and 5 into e power kt got cancelled. Why? Because y means we already know that y means 5 into e power kt. So 2 by 100 means 0.02. So we are getting a constant value. So that's it. Therefore, hence the equation is y is equal to 5 into e power 0.02 into t. So it is a complete equation. This is the equation refers the growth rate on the particular value. So second question we will solve. Okay. Second question. Again take y is equal to y naught into e power kt. Okay. So the conditions are two different conditions they mentioned. So they said y of 1 is equal to 1 and y of 10 is equal to 100. Y of 1 is equal to 1, y of 10 is equal to 100. Now I am going to substitute these two values. Here, if you observe this value, this indicates y naught is equal to 1 at initial, t value 1. And here in this situation, y naught is equal to 100, t value 10. Okay, we will substitute these values in the first equation. First, we will write y is equal to y naught means 1, e power kt means k into 1. Okay, uh, here in this equation, we're going to substitute these values. Y is equal to y naught means 100 e power 10 into, k, 10 into k, because t value is 10. Okay, understood this part? Just substituted that values. Now we will divide both of these values. Dividing say 2 comma 3. From 2 comma 3, from 2 comma 3, you can equate these values. 100 into e power 10k is equal to 1 into e power k. Okay. So therefore, this will be how much? This will be e power 9k is equal to 1 by 100. Fine. E power 9k is equal to 100. So 9k is equal to 100 or what? Third one, the surface area of a balloon being inflated changes at the rate of proportion to the time. If initial radius is 1 unit and after 1 second it is 3 units, find radius after t. That means he is asking the general solution. Okay, let r be the radius of the balloon, okay, at a time t. T is equal to time. So inflation, he said, that means d by dt of inflation means what? Volume, right? It's volume. Surface area, particularly he mentioned that surface area, not volume, surface area. Surface area, how it was is proportional to the time. So you can write d by dt of 4 pi r square, surface area of a balloon, equal to, you can write k into t. You have to find the unknown things here. The main unknown thing is k. We have to calculate the k value. Okay. So what we do is we will integrating to remove this part. So if you are integrating, then d by dt was removed and k into, you have t square by 2, t derivative, t's integration plus c. The initial conditions are t0 and radius 1 unit, 1 unit. He said radius is 1 unit at initial. If initially, if you check the question, you can find that. If initially the radius is 1 unit, he said. So t value 0, r value 1. So therefore, we have 4 pi into 1 square. This is the main equation, is equal to k into 1 by 2 plus c. Sorry, t value 0 here. So 4 pi is equal to c. So that means we got the constant value. So you can replace the constant value here in this equation, first equation. From first equation, 4 pi r square is equal to k into t square by 2 plus 4 pi. I just replaced this c value. Okay, again, what is unknown thing here? K value. Okay, we are going to calculate that part also. So he said one more thing, that when 1 second, at 1 second, radius will be 3 units, he said. Okay, again we will substitute these conditions in this second part of the equation. So 4 pi into 3 square is equal to uh, k into 1 square by 2 plus 4 pi. Okay, so this is 9 fours are 36 pi minus 4 pi is equal to k by 2. So this will be 32 pi, okay, is equal to k by 2. From this equation, you are getting k is equal to 64 pi. Okay, again we got the k value. Therefore, we can derive the equation now. Okay, so from first equation, 4 pi r square is equal to, what is the equation actually? The equation is k into t square by 2 plus 4 pi. Now, so in this equation, we will replace k value. So 4 pi r square is equal to 64 pi into t square by 2 plus 4 pi. I just replaced the k value. Okay, t got cancelled 64 in 32 times. Now overall, you can cancel pi. You can cancel pi overall. You can cancel 4 table also. It goes to 8 times. It goes to 1 time. So r square is equal to 8t square plus 1. Now what is r then? R value is equal to 8t square plus 1. Now this is the answer for the question. He asked that calculate the radius at any time. Find the radius at time t. So how will be the radius at time t? 8t square plus 1. Okay. Next question. Fourth question. The population growth rate is 2% per year. How long does it take the population to double itself? So population will be double. E be the population. Rate of change is 2%. Rate of change is 2%. And P naught be the initial population. Initial population. Okay. P naught be the initial population. So we have the differential equation dp by dt, rate of change is 2% of P. 2% of P. 2% means 2 by 100 of P. So 1 by P into dP is equal to 2 by 100 into dt. So integral 1 by P dP is equal to integral 2 by 100 into dt. Solve this differential equation. Log P is equal to 0.02 into T plus C. Okay. We have two initial conditions. So at initial stage, P value will be P naught and time will be 0.